Hello everyone, welcome to the tutorial on bubble sort program implementation demo. This tutorial is basically a continuation of the bubble sort program. The logic of the program was explained there, and I will add the link in the description box. So in this tutorial we will be only explaining how the program can be implemented using the KEIL microvision software. And the device that we have used is Texas Instruments TM4C123GH6PM, and software used is KEIL Microvision 5. So let us quickly go to the demo. So first, create a new microvision project. You can give any name. I will give it as 123. Here, since we are using Texas Instrument and the device is TM4C123GH6PM, I'm directly going to search for it. Or you can browse through Texas Instrument, go to TIVA-C series, and then under TM4C123CX series you can find this device. So instead, since I know the exact device, I have typed it here. I'll click on OK. Here, make sure that your core is selected, and I will go to the device, go to startup and check that. Make sure that system startup for Texas Instruments TM4C123X series is ticked. Then I will click OK. Once that is done, I need to right click on source group 1, add new item to the group source 1, and since this program is a C program, I'm going to click on C file.c, give a name. Since it's a bubble sort program, I will give it as BUBL. Any name can be given. Now once this is done, you can see there is this window, editor window, that is opened. So here in this editor window you need to type the program. So this is my program which I had explained in the previous tutorial, where I am having an array of data and I have considered the same array of data which I had explained in the example. So this program makes use of three variables basically, I, j and temporary, which are initially initialized as 0. We need to make use of two for loops. One is the outer loop and one more is the inner loop. So we are basically comparing every individual element in this particular data with the adjacent element. So 10 is compared with 20, and if it is greater than or less than, depending on the program that you have written, we are going to perform the swapping. And I've also explained you as to why we are making this or comparing this with the value 9. Since we have 10 data elements, we have to consider the comparisons to be the number of data minus 1. So 9 has been considered. And this program is basically meant for arranging the data in the descending order. So you can see we are going to perform the swapping if we find that the data of 0 is less than the data of 1. Okay. And once you perform the swapping, since we need to make use of the temp variable once again, that is why we are initializing it with 0 again. So once this is done, once you write the code, make sure that your system tmc123.c startup is having all the necessary core systems and .h files. And once that is done, we will go to save and we will try to check for any syntax errors. So that is why you can go to debug. You can go to building the project to check the errors. You can directly click on this icon, or you can go to project and build target. So if you observe here, there are no errors in my code, so that is why I am getting 0 errors and 0 warnings. You can see here in this particular console, in your output console, you can observe here build output, 0 errors and 0 warnings. That means my program is perfectly fine. So once this is done, we will go to debug. Once this is done, we will go to project. There options for target 1 is there. We will select that and we will check our device once whether our device is correctly selected or no. So here you can see my device is perfectly selected like the way I wanted it to be. Then you can go to debug, and here in the debug, since we are doing only simulation part here, so we do not want to choose ULink to Mi Cortex debugger. Instead we will go to use simulator option. Okay, so if you observe now, this use ULink to Mi Cortex debugger or any other, okay, if you are going to use Tiva C series, generally we use a different debugger, that is ICDCI. So in such cases you need to make sure that you are installing the right packages, so make sure of that. So here we are only performing the simulation part, so I will check on use simulator, click on OK, and once that is done I will start with my debug. So debug, start stop debug session. Okay, so if you observe here, you have a register window and you have this call stack plus locals window. If this particular window is not visible in your case, what you can do is you can always go to view option and here click on call stack window and observe. Even the register window, if it's not available to you, always go to view option and choose those windows. In my case, the moment I did the debug, this window was already available, and adjacent to this you can observe that there is a memory window that is present. Okay, so when you open the memory window, by default whatever program was executed previously corresponding to that particular address, you can see some data, but this is not meant for us right now. So I am now interested in running this particular code. So what I will do is, in call stack plus locals, I am going to just expand this data. Okay, so if you observe here, I have considered data of 10 elements, right? So that is why I have data 0 to 9, and this is looking empty because I have not still started with my execution. So I will go here and do the step in execution. I need not be bothered about the register contents currently. That is because we are not writing an assembly language program here, so we are not bothered about what is getting stored in the registers. For us, what is important is what is going to be stored in the memory at the end is what we need to observe. Whether the program, if the program was written for arranging in descending order, we need to check whether the program arranges it in the descending order or no. And since 3 variables were used, you can also see here in the stack, call stack plus locals, the variables I, j and temp. So I will do the step in execution, and you can see when I did one step in execution, you can see where the data has been storing. Okay, so here you can see the location or the address. So it is 0x2000224. So this is the address, and let me do once more, and you can observe the entire 10 elements being appearing here: 10, 20, 30, 40, 50, 60, 70, 80, 1 and 2. In the same order it has been stored. So now what happens is, since we have used 2 for loops, initialized it with 0 in the beginning, that is why you can see I and j are all zeros, and even the temporary is also initialized with 0. So let me start with the execution and running the code. I haven't given breakpoints in the program, that is because I want to show you at each stage what's happening. So here you can see in the first step I and j both are 0, and you are comparing data of 0 with data of 1. So you are basically comparing 10 and 20, and after it swaps, after comparison, when you realize that 10 is less than 20, you are performing the swapping, and the one data that is there in data of 1 gets moved to gets moved to the data of 0, and the lower data of 10 that is there, that gets moved to data of 1. So if you see in the temporary variable, initially you are having 10. When I do one more step in execution, you can see after the swapping, data of 0 is having 20 and data of 1 is having 10. So between 10 and 20, what we have done is we have arranged these two data elements in the descending order, because this program is meant for arranging the data in the descending order. So we have done it between these two elements. Next, what we are going to do is we will be initializing temp with 0 again, and we are going to move to the next set of data elements. So now j is initialized with 1. That means you are comparing data of 1 with data of 2. So you are comparing what was stored here now is 10, and you are comparing 10 and 30. So you can see, you can observe the call stacks plus locals. So if you see here, data of 1 is now arranged with 30 and data of 2 is having a value 10. So between these two, between data of 1 and data of 2, again we have arranged it in descending order. So this way we are going to progress through the entire loop. So here you can observe how the value of j is changing, and then you can see once j finishes its iteration up till 9, it increments I. So as you observe, the value of j is incrementing, and the moment the value of j becomes 9, value of I gets incremented. That means once you have finished the entire line of data by arranging it in descending order, you are again going to start by incrementing the value of I, and again you are comparing every element with every other adjacent element. So this way you can perform the complete execution. I will quickly run through the code. So here if you see, j has become equal to 8, and the moment I go for the next step in, the value of I also becomes equal to 9, and then you are done with the execution. Okay, so now if you want to observe whether how the data is arranged, so here you can see I have typed that same address whichever was there in the call stack plus locals, and you can see 80, 70, 60. If you want to observe, let me just compress this part. So it is 80, 70, 60, 50, 40, 30, 20, 10, 2 and 1. So till 0x200248 is our data. After that you have some data which is not completely relevant to us, and this mainly occurs because of some external factors like some debugging artifacts or some unrelated code impacting the memory. So we need not bother about that. We can just focus on our data which we have used only till 0x200248. So here what's important is that we need to keep observing our memory, because sometimes some extra data might simply be uninitialized in the stack memory which is adjacent to the data array. So we should make sure that we can use some breakpoints and inspect the memory region corresponding to our data only. Okay, so this is what is very much relevant to us from 80 to 1. Now let me just show this once again for arranging the data in the ascending order. So all I need to do is I need to just let me stop this once and just change this particular symbol. I'll close this. Okay, since I had closed the window, let me just open the call stack window now. Step in execution, and you can see this is my address that I need to consider, 200224. So when I'm going to type the address in the memory window, it has to be that same address corresponding to that particular location. where I will be able to observe whether my data is getting arranged in the ascending order. So here you can see the same data has been loaded. So here if you see, I have just changed this symbol to greater symbol, and now I'm going to start with the comparison. J is equal to 0, temp and I is also equal to 0. So let us start. So you are comparing 10 and 20. So for J is equal to 0 and J is equal to 1, if you observe here, you are comparing if 10 is greater than 20, right? So 10 is not greater than 20, so that is why you need to perform the swapping. So if you observe now, data of 0 is loaded with 20 and data of 1 is loaded with 10. So you have finished arranging these two, okay, by swapping these two. Next you need to move to the next one, that is means you are comparing 20 and 30. So you are comparing and checking whether 20 is great, whether now 10 is greater than 30 or no. So again if you see, you have swapped it because it is not greater, and this way you are going to proceed through the entire program. Okay, so let me just complete this particular execution and go to the memory window and directly check how the output is getting displayed. So here if you observe, you can see how the data has been arranged in the ascending order 1 to 10 up till 80. So as I told you previously also, some unwanted data also will be available to you because of some sort of corruption. So we can correct this particular thing by fixing the loop boundary and ensuring that we have initialized correctly. This is my actual data that you can see, which has been arranged in the ascending order.